welcome back. It's great to have you here today. Today we'll be going through 5 EMC style questions. I recommend trying these questions yourself first. You can find the link to the question in the description box. If you need to review the content before attempting these questions, the playlist might also be helpful. Now let's get started. In this first question, we are given an equation of a circle x squared plus y squared equals 25. Y take away 3x equals 13 is the equation of a straight line. So the best way to solve this problem is to make y the subject in the second equation. So y is 3x plus 13. And because we know these two y's are the same, so we can substitute the y back into the first equation. Now we have x squared plus 3x plus 13 squared equals 25. Now by expanding the brackets and collect the like term, we can see that we have a quadratic equation. So we can factorize out 2 to make the equation simpler. What I need to do next is to use a Farmer's field to factorize the quadratic equation. 5 times 72 is 360. I need to find two numbers that multiply to give me 360 and add to give me 39, and that is 15 and 24. Now we need to put 15x and 24x back into the Farmer's field. Now it doesn't matter which way you do it, we will get the same answer. This quadratic can be factorized into 5x plus 24 and x plus 3. So to solve this equation, we need to let 5x plus 24 equal to 0, and x is negative 24 over 5. We can then use the second equation to find y. X plus 3 can also be 0, x is negative 3. And we can solve for y, which is 4. Okay, so that is this question. Moving on to the next one. We are also given two equations. The first one, y take away 2 over x plus 1 equals 5. And y take away x is 6. I can also make y the subject in the second equation. Now I'm going to do it in using a different method, just so that we can do a quick revision of all different methods. I can make y the subject in the first equation as well. Now I set these two equal to each other. In order to get rid of the denominator x plus 1, I will multiply all terms by x plus 1. So that will give me 5 brackets x plus 1 plus 2. And that equals 6 times x plus 1 and x times x plus 1. By expanding the brackets and collecting the like terms, we can simplify the equation to x squared plus 2x take away 1 equal to 0. Okay, now if you try to factorize this equation, you will notice very quickly that we can't do it. Another way to solve it is by using quadratic formula, or I can complete the square. So in this question, I'm going to complete the square, and we have x plus 1 squared equals 2. Taking the square root of both sides. Now remember, a negative squared can also give us a positive value. So x plus 1 can be positive or negative square root of 2. Taking away 1 on both sides, now we have two answers for x. One is negative 1 plus root 2. The other one is negative 1 take away root 2. And we know y is 6 plus x. Therefore, when x is negative 1 plus root 2, we have 5 plus root 2 as its y value. However, if x is negative 1 take away root 2, then we have y to be 5 take away root 2. In this question, we also have two solutions. Okay, now moving on to the next one. Now in this question, we have to form simultaneous equation ourselves. Now, Amy thinks of a fraction. Now, I don't know what that fraction is, but we know it's going to be a over b or x over y. It doesn't matter which letters you use. So that a over b is the fraction Amy thinks of. If Amy adds 1 to the numerator and the denominator, this fraction is going to be 3 over 5. If Amy subtracts 4 from the numerator and the denominator, the fraction is going to be 1 over 5. So we can set up this simultaneous equation. Now at first, it might look difficult to solve. So here, I have a trick for you. If we have two fractions equal to each other, for example, a over b is equal to x over y, what I can do is multiply b on both sides to get rid of the denominator. I then can multiply both sides by y to get rid of the denominator on the right-hand side. So now we have an equation ay equals bx. Now, if you look at the fraction, if I cross multiply, ay is going to be bx. This is a trick you can use. So now coming back to our question, we can cross multiply and we have 5 times a plus 1. Now a plus 1 need to be in brackets because that is our numerator, is equal to 3 lots of b plus 1. Similarly, the second fraction, 5 lots of a take away 4 is equal to b take away 4. So now what we can do is with rearranging and simplify the equation, we will have a simultaneous equation. 5a take away 3b is -2. 5a take away b is 16. As we can see, we have 5a in both equations. So what we can do is to do 2 take away 1. Now, if you wanted to do 1 take away 2, you will end up with the same answer. But the reason why I go for 2 take away 1 is because then that will leave us with a positive value. -b take away -3b, that is 2b. 16 take away -2 is 18. So 2b is 18, b is going to be 9. There are many equations we can use to find a. A take away 4 over 9 take away 4 is 1 over 5. Then that means a take away 4 must be 1. A therefore is going to be 5. So the fraction that Amy thinks of is 5 over 9. Okay, now let's move on to the next question. This question, it looks more complicated, but actually if you make the right decision, this question is very easy. So the table shows a few values that satisfy the equation y equals a cos x plus b. If x is 0, y is 3. If x is 30, y is 1 plus root 3. If x is 60, y is going to be 2. If x is 90, y is going to be 1, etc. So I probably don't want to use the one that involves surds. For example, when x is 30, y is 1 plus root 3. What I'm going to do is I'm going to use the first one. When x is 0, y is 3. So then I know a cos 0 plus b is going to be 3. I will also use the fourth one because I know cos 90 is a nice number. A cos 90 plus b is going to be 1. Now cos 0, think about the graph. Cos 0 is 1. So from the first equation we know a plus b is 3. Cos 90 is 0. So then that means 0a plus b is 1. So that tells us b is 1. So if b is 1, a plus b is 3. That tells us a is going to be 2. So we find the equation y equals 2 cos x plus 1. Now the question wants us to find y when x is 45. So cos 45 is root 2 over 2. 2 times root 2 over 2 plus 1 give us root 2 plus 1. And we can leave this as our final answer. Okay, so now moving on to the final question. Now this question is slightly harder. Sam swims 2.3 kilometers in 1 hour. Some of this swim is front crawl, and the speed is 3.2 kilometers per hour, and the rest is breaststroke at 2 kilometers per hour. What distance did Sam swim using breaststroke? So what we want to find is the distance of both journeys. So we can let x be the distance that Sam swims using front crawl, and then y be the distance that Sam swims using breaststroke. Now in this question, there are some hidden information. We are given the speed, and now we need to work out the distance. Now we know speed equals distance over time. We know that the total distance is 2.3 kilometers. So that means x plus y needed to be 2.3. Now the total time is 1 hour. We haven't been given any information about the time of each journey, but we are given the speed. So speed equals distance over time. When using front crawl, the time is x over 3.2. When using breaststroke, the time taken is y over 2. So now we know x over 3.2 plus y over 2 needs to be 1. Now we have two equations. With this one, you probably want to make y the subject or x the subject in the first equation and then substitute into the second equation. Now in this case, I'm going to multiply the second equation by 2, and that will give me 2x over 3.2 plus y equals 2. And I'm going to call that equation 3. Because I have y and y in the first and second equation, I'm going to subtract 3 from 1. And then that will give me 3 over 8x equals 0.3. By solving the equation, x is 4 over 5. Now substitute back into the first equation, x plus y is 2.3. We can find out that y is 1.5. Now let's just quickly go back to the question. Remind ourselves, what does the question want? The question wants us to find the distance that Sam swam using breaststroke. So the answer is 1.5. Okay, so that is it for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport, and you have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.